Hello friends, welcome to our channel Tech on Target. Today we are going to discuss some frequently asked questions regarding Kubernetes in interviews. So let's start. Before starting the video, this is the code. The way to get started is you should start doing the things to begin the things. So let's start with the first question of today. We will start with some basic and with increasing we will touch the advanced concept. When we talk about the Kubernetes, it is an orchestration tool and there are other orchestration are also available like token swarm. How it is it different from or like from Docker Swarm? There are some feature like installation and cluster config, GUI scalability, auto scaling, rolling, and load balancing. We can differentiate Kubernetes from Docker Swarm on these behalf. As you can see in Kubernetes setup is very complicated. If you are going to set up your own setup of Kubernetes in your on-prem, it's getting very difficult. But in today time we have AWS, so we don't much have to make time on that. In respect of that, Docker Swarm installation is very easy. There is a GUI is available, and there is no GUI available here. Highly scalable, and it scales fast. And Docker Swarm is also fast, and but Docker Swarm can't provide the auto scaling. That's a major drawback because as per our current scenario requirement, when we are dealing with the environment, like we have a different kind of clients like Flipkart, Amazon, which is holding their application at a certain time. Their like we have bank website in the daytime it have much traffic and in nighttime don't have traffic, so we should have the auto scale plus scale down feature. So load balancing is also the part here, and rolling updates and rollback. We can deploy rolling updates and does the automatic rollback in Kubernetes, but we can deploy Docker Swarm with the Docker Swarm, the rolling and updates, but automatic rollback is not available. Uh, okay, I think we have many points to and we have a sense of clarity in our mind regarding Docker Swarm and Kubernetes. So we now move to our next question. It should be our first question, but in many of time, uh, interviewer can ask you that what is the Kubernetes. So Kubernetes, what is in your understanding? If you are working in some projects you have experienced, or what is the problem a Kubernetes solving, and what is that? Kubernetes is mainly it is an open source container orchestration tool, and it is used to manage monitoring, scaling, deploying of containerized application. Whatever the application we are hosting in container, we can host it under Kubernetes cluster and perform these many tasks on that. So next move to the next question. How are Kubernetes and Docker related? As we have studied just what is Kubernetes. Kubernetes is a container orchestration tool. So we have the Kubernetes to deal with the containers, and container might be of Docker. There are also other container are also available. So Kubernetes is like player who play with the and Docker are the tools like bat, ball, and ground pitch for that uh, particular game. So Kubernetes is the player and Docker are the tools for that particular weekend for that game. So same is the definition I have written out there. What is the container orchestration? As container orchestration is the managing the container, like we have we have an application which have a front end, back end, database, middleware layer, and this is our fully containerized layer. All application are in the form of the containerization. So if we can deploy application directly on container like Docker, but what the difficulty we will find to scale, to manage their auto scaling and descaling plus their networking is very difficult task. And while we try to means we can try to auto scale, but it will create a problem for that. So that for that purpose we use the container orchestration tools. Kubernetes is also one of the orchestration tool. There are other like Docker Swarm, others are many options are there. So it's make the DevOps or your developer task easy to manage the your container environment application becomes very easy with the container orchestration tool. So it's the fifth question. What is the need of the orchestration tool? Need, we can say that if think about the scenario where we don't have the Kubernetes and other tool, we can have Docker simple like I have a front end layer, okay, of Nginx or whatever the webserver you have that you have hosted on a one VM, okay, and then on the other VM you have the middleware maybe you are using some client. Then in the last you have databases, or either you are doing the RDMS managed database service. But when you your application will auto scale, you have will find that this is get very difficult to you. Plus there are out of the fixed box features available in the Kubernetes like rollback and maybe rolling the new updates in the like you are working on a version 1 and now you have to move to version 2. Making update in your live environment is become very systematical and manageable way by using the container orchestration tool. uh, you can see here there are some points. It controls the automation various tasks, deployment, scaling. That's we have already reduced the complexity of the running time. Scale become easy and used to deploy the manage complex containers application, reduce manual setting up services. Okay. Okay, what is the difference between deploying application on host and containers? It is like that. Think of like we have taken the example of the Nginx. If we deploy application on the host, in the host uh, uh, we have to, if I have deployed one application on this host, so I have downloaded installed some libraries on that our app is working. We have OS layer, then we have kernel layer. On that we are deploying our libraries. On that our application will be run. If I want to add I think we can say more application, it can do interfere with that because they are on same platform. But uh, when we do container like on the same VM, I am having Nginx and Apache we are using for Java application. So when we are having these two, plus we can have the middleware layer, plus we have can the other layer, other layer or container also. The all the libraries will remain under this particular container, and it will not interfere with the other containers. They will remain independent of the others. That's the main benefit of I suppose and I observe, I experience in the container environment. Same you will find the in the answer. So let's move to next. What are the feature of Kubernetes? Feature, if we talk about the feature, there are multiple feature like service discovery, networking, communication between the containers becomes very systematical and easy, and load balancing, like we have services of different services available in our Kubernetes, they can act as a load balance. Like we have a service of cluster IP of particular web server, and under web server we have three container of the nginx. It will equally distribute the request to all three, as service by default can do the task of load balancing. Storage orchestration, like we have making the stateful sets, plus self-healing. Self-healing feature makes the container orchestration much rich than our normal, we can say, in the normal host plus normal container environment, we can't achieve that. Like we are configuring the props. With these props make like our application code down. Container will stop, and liveness will found that container is not, and it will restart. Restart means deleting the old and again continue with the new container. So we will have whatever the time we have provision, 15 or 20, whatever the 27, whatever the provision. After that, your new container will be launched and your application will become live within sports span. Otherwise, it will take much time to heal these. And secret and configuration management, like in the while we are using it is the challenge there, where we will save the configuration management and secret management. Here we have the config map, secret map. With that we can manage thing with much systematically, and batch execution, horizontal scaling, automation, automatic rollback and rollouts. Uh, Rollouts plus rollback, uh, doing rollback and rollback is very easy compared to if we directly want to do deployment and rollback under Docker. So I think we are clear with that. How does Kubernetes simplify the container employment deployment? Okay. Application deployment require web tier, application tier, database tier. All this requirement will multiple container, and these container require communication, and among this can be taken care by the Kubernetes, and which otherwise if you are configuring the Docker environment, it would become very complex task. Whole the it not only Kubernetes. If you are using the other orchestration tool, it will take all the system problem and take care of the all the networking. Like you have 3 worker node, 4 worker node, doesn't matter. One port will communicate with the other port the way you define that by using service. That's the other fact, but the way you define it will talk to that. Okay, let's move to the next question. uh, what is GKE, AKS and EKS? These are the there are major 3 cloud service provider: Google, Azure and EKS, and they are also providing the Kubernetes service. So these are the services, Kubernetes service provided by them, and these are hosted on their platform. Like Google Kubernetes Engine, Azure Kubernetes, it's not engine, it is service here, and uh, other one is Elastic Kubernetes Services. Okay. What is kubectl? Uh, Actually, when we pass the commands to the Kubernetes cluster or Kubernetes server, like we have a Kubernetes server, either is on your on-prem system or on cloud. There are more clouds are also available. Uh, DigitalOcean is also there. Other one also available. So how we can interact with that? Through GUI. GUI is not taken as the preferred way because reusability decreases very much. So we need to do deployment via code through CI/CD. For that, we need some steps written. So we have the kubectl. It is the Kubernetes command line tool which allow us to run the Kubernetes command in the Kubernetes cluster, and we can manage the resources, deploy the Kubernetes objects, delete them, whatever we want to do. We can fully talk with the Kubernetes API server to get the job done, whatever we require. What is the kubelet? It is the part of the, we can say, the main architecture diagram uh, of the Kubernetes. I have made it the playlist. If we go here, what is the and different options are here available. Uh, Different things I have covered both in Hindi and English language. Whichever you prefer, you can go and you can take benefit from that if it's increase your learning. So Kubernetes is the primary node agent which is available on the worker node where we are deploying. We never deploy our application on master node. Master node component are different. We will deploy the kubelet on uh, the primary node, and it will its main task is to control the pods over there and make them working. So what are the different, okay, in that particular question we have master node plus we have worker node. That's the thing, clear? uh, Master node is the main application of the Kubernetes, and in the worker node we deploy our application. Like I am we are going to host a bank application, so we will host it on the worker node. It will never get hosted on the master node. So let's start with the master node. On the master node, uh, one thing, we have the schedule. We will start with the API server. API server is the main part of the Kubernetes who can interact with the any object of the cluster. Like API server in this picture is communicating with the worker node. It is also communicating with the uh, control manager and with the etc and with the scheduler. And there is a one more part. When we are on the cloud, it has the cloud manager which help it to connect to the cloud. So okay, here API server is used for the APIs of the Kubernetes, and controller manager task is to uh, control the Kubernetes. Scheduler, what scheduler do? Its task, major task is the to schedule the pods or container on the worker node, where it will schedule it, get scheduled. Like we have 3 worker node where our pod will be get scheduled. These things we will decide by the scheduler. And etc is not the basic part of the Kubernetes. It's also get used in other projects. It acts as the database for the Kubernetes. Whatever commands we are passing, whatever things we are creating, we are creating deployment, replica set, replica controller, daemon set, everything is written under this. When we hit the API, it will write under it that check with the control manager. Control manager send the signal to API server back, and API server will, if it's get approved, will send to the scheduler. Scheduler will check and give it result or to API server. API server write that in the etcd and then create the pods in the worker node, and then again it's right in the etcd that they are created. That's the part of the control plane or master node. Then we have worker node. Worker node we have to kubelet or kubeproxy. Then we have the your our application pod. That's the different thing. That's the main. These two are the main part of the Kubernetes cluster. Kubelet we have seen it's used to control the pods, and what is the key proxy doing it for the networking? How like we require some networking uh, networking help in the to talk with the like to work with the pod. Like we have a service of cluster IP or not cluster, not node pod, and how it will really work. It make the things workable by using the kube proxy. So I think we are clear with that. If you want go in the more detail, you can go to our channel and watch the video. Okay, what are the different type of services in the Kubernetes? In the Kubernetes, we have four type of service: cluster IP, node pod, load balancer, and external name. Cluster IP is used to communicate within the cluster. Node pod is used. Uh, there are node pod is like your application is deployed on the worker node, and this worker node has a specific IP, and from I think 30,000 to 32,000 something ports are there on that. Oh, out of which that port, one port is assigned, and a node port IP is assigned, a service IP is assigned, and if we hit on that service IP, like we have done an installation of Nginx, which is which have a port of port 80, and but if we are using service IP will listen on that 8 port, and whoever is accessing from outside, it will give us a port of particular 30,000 to that specific port. And then we have the load balancer. Load balancer is the widely used service when we are on cloud. uh, it uh, it is an object of service provided by the load balancer by and under that basically we have the classical load balancer, which give us a DNS in some cloud provider we have DNS, or in some we have IP. If we hit on that IP, or we will hit get response from that particular node, like uh, we am hitting on the load balancer IP, and this load balancer IP redirect the traffic to that particular port traffic. And then we have the external name. External name is not that much used, but it is very useful. Like uh, we have a namespace of dev, and we have a namespace of dev. One is dev app and one is dev database. So my application in the dev app need to communicate with the database set is allocate which is created in the dev db. So what we can use in the dev db, we have the service of mysql. I have to create an external name service in the dev app by name of mysql, which is uh, redirecting it to the dev db pod. So it is majorly used to communicate between the two namespaces. Otherwise, you can't communicate uh, between the two different namespaces. So I think this use case is clear to you. Now we can move to next. What is Ingress and how it's work? Actually, Ingress is basically a Kubernetes object. Sometimes we confuse it with the service. If it is a not in service, service will remain load balancer. But when we use the load balancer, we if like like I have a Grafana, Prometheus, and alert manager is configured, and I want to access the Prometheus, and I assign a load balancer. But now I have to access the Grafana. What can I do? I have to take other load balancer. And for alert manager, if I want to access on web portal, I have to take three different load balancer. But what if I have in the same NS, ELK is also configured? Uh, Last research, I have to configure the multiple load balancer. It will uh, create the huge bill for your organization which you are working. So what we can use, by using a single load balancer, we can have this. By using single load balancer, we can create different rules, and according to that rules, our traffic will flow to two particulars. Like for slash grafana, it will redirect the traffic to grafana, particular grafana node or port which we're using. And if we do the slash, like IP of the, we can take IP of the load balancer and slash grafana, it will, and that's why with these things it will work. So same, it will be used to utilize the proper way the load balancer. Plus uh, if we are want to make the secure communication, it's preferable to use any traffic which is want to access from outside of Kubernetes cluster. It should come through the Ingress, and we can make them secure by using the certificates, or we can do the communication over the HTTPS by using a client certificate. So okay, now we can move to the next question. What do you understand by the cloud control manager? Actually, when we are discussing the its basic architecture, we have seen that there is a part which is having the name of cloud controller manager. So what this part really do? It's act as a gateway for the Kubernetes cluster to communicate with the cloud, and it's act as an abstraction from cloud specific code from the Kubernetes code, and manage the communication also. And if you want, like load balancer service, load balancer is then object or it is service of the cloud. Kubernetes not hold that, and we are configuring Ingress rules under Kubernetes cluster, and also we are deploying the Kubernetes Ingress controller over that. So how this connection will be made is connection will be made via cloud controller manager. Okay, and there are other also connection also things which is done by this cloud controller manager. Okay, this question, actually replica controller is not used in today world. We really don't use the replicas controller. We use the replica set, and more we use the deployments where we need, and let's see what is the difference between the replica set. It can be asked in the interview. Actually, when we have to do equity based selection, we are using the replica controller. But uh, if we have to make the set based selector, then we have to choose the uh, replica set. So what these terms really mean, equity based and set based. Equity based, like I want my pod to get allocated, uh, I want the replica set. Replica set, what replica set do? They both make, they both ensure a specific number of port. Like in the replica controller, I have passed wherever you will find app is equal to nginx, you have to make sure that 3 ports are available, 3 replicas are available. So, okay, that's the case of the controller. It will check whichever port have the label of app is equal to nginx, it will make its count and scale to 3. Okay, but when I want to choose app is equal to nginx, or wherever we have app is equal to we can say Apache, app is equal to Tomcat, you have to make the replica equal to 3. That can't be achievable with the replica controller. This thing is achievable with the replica set. You are understanding? Like app, either app is equal to Nginx, either app is equal to Apache, either app is equal to Tomcat. Make the replicas and count of that ports equal to 3. So that's the main difference between the replica set and replica controller. Okay, what is the headless service? Uh, when there is, I have tell you in the some early part of the video that service can act as a load balancing, and IP address is assigned. When we use the cluster IP and in the setting we can write the cluster IP is equal to none, it will act as an uh, headless service. So where no load balancing and no IP will be allocated, and we can communicate via direct uh, using its own IP. So why we are using that? Why we don't want the load balancing? Its majorly use case is involved in the making the stateful service like database, where I want uh, it's to go to a particular port, like uh, while we are working in a database, and one thing it will write in this database, one thing it write in other database, and this will make a cause and your application will not work. It will have to make the record in one place, so that if we are adding the 1000 and from other we are reducing the 5000, we can't have two balances. One is showing the 1000 balance in one database, other one showing the 500 balance reduction. So I hope this is clear with you are clear with the headless service. Whenever we have to deploy a stateful set service like MongoDB or whatever you are in a single pod, then you can use the headless service. What are some example of recommended security measure for Kubernetes? Uh, we can use like we can take the example, we can define the resource quota, so that particular resource can't exceed that limit to make down the all the application and create the problem for other application. Either we have uh, deployed the we use auto scaling in the worker node, but there is a one pod which not behaving correct, and it getting uh, it's maybe it's get corrupted or it's started to take the resources much, like it's consumed 32 GB memory, but in the reality it like we can assume that it's janking. It's supposed to take only 4 RAM is enough. In the most of the cases it may go up to 8 or 12 in specific, but my use case is not that, my application are not that much heavy. We have to move that 20 GB, so there is some risk involved, so we can make restrict the thing as we know what our application is going to request. Restriction of it, if we have our own uh, on our maybe on-prem system, who can access the etcd, it should be restricted. Only few member who are matlab, they are major person in your corporate uh, should have only access, because if someone deleted the things from etcd, everything will go down and can't be recoverable. So we can do backup another thing, but for backup we shouldn't give. Okay, your environment, if you have configured the different environment, you should update the regular security one. You can rotate the keys and other stuff. Network segmentation, we can do a definition of strict resource policy. Yeah, you most of the things are we have to manage in the on-prem or our self-hosted system. Okay, there are some app available which help us the uh, to find the vulnerabilities. Vulnerabilities, you are understanding from where we are weak. How we can find uh, by from where we are vulnerable. From where, like I am, my one hand is get broken in accident. So if someone is want to hit me, this is my weak part. If it attack on that, much chances are that he win. So we have to work on our weak part to make them strong. So we are ready to any attack, and we will stay healthy after that attack using images from authorizable. Yes, like there are images are there, and helm chart we are using. Like there are help chart are available for, I think, for one application there are 10 to 20 or maybe more help chart are available. We should only use the helm chart. Like if Jenkins should provided WordPress organization chart we should prefer in any case. If you are not preferring the some due to some any reason, you can create problem for your organization. Okay. This question look much on scenario based. Currently, your organization has a monolithic architecture, and they want to shift on. They want to scale at their wish. They can scale on that monolithic wish monolithic structure. But the best way to scale, they should choose a containerized service operation tool and deploy their application on uh, the containerization. So what you would suggest? So like when we use the Kubernetes or specifically Kubernetes, like uh, we will separate the all the component, front end and its web server on other port, middleware layer. If you have Java application, .NET application, PHP application, that on other like you have database, either using the managed database, or if you're not, you can create that in the alag names other namespace. You in this same cluster you can create the different environment, QA, dev, prod, and you will pick the component and start deploying one and two, do the testing on that. Then one by one you will align all the component and uh, create the infra on your uh, dev environment. Once you test uh, from your monolithic, you are not going to do the dev application on that. Now you test it on your dev and create environment for QA and test it over there. And if everything is get succeeded, all your component, all your ports are working in a sync, and there is no uh, problem in your website or whatever application experience, you can go to prod and live it. That's my approach. One solution. What do you say? You have to configure your solution. So we can move to next question. Okay. What is the use of namespace in Kubernetes? Uh, like in Azure, if someone is using Azure, we have resource group. Resource group provide a logical boundary between the resources. Like we have LB, VNet, subnet, VMSS, other stuff, virtual network, uh, private virtual links are there. Uh, there are multiple things. All like you have a dev environment, you have a resource for dev environment. All the things will remain. You can find on single resource group. Same like we have the namespace. Like in we have a namespace of monitoring. In under that we have our resources of monitoring like Grafana, Prometheus, Alert Manager, and others. We can host them on a single namespace like monitoring, and whenever we will run the command use, it will get NS and see the resources. We will have all the resources which is available there, and in that way we can manage the things, and plus it provided logical boundary between resources of one namespace and other namespace. You can find that other namespace service you can't call there. There are ways are available by external name, but directly not there. So it is much too in the logical boundaries we can define by using namespace. What is node selector and its use case? Uh, if we talk about the node selector, uh, we want to schedule our pods on some specific node. So in that case, we use that. Maybe our application is very highly memory optimized. If it don't get the highly optimized memory, it will affect it, degrade its performance. So what we will do, we will put a node selector on that. It will only will get selected on that node selector. Same video we have on our channel. If you want to go in detail, you can go there. Next question, we have node affinity and its use case. Node affinity is the enhanced form of the node selector, if we can say. It's enhanced form. Enhanced form means node selector while make decision, it's not that flexible. It's go for just a decision like instance type is equal to medium. It's can if instance type is medium or large, you can schedule that, but it will not schedule. It will only look for medium. Either we have availability of the large instance, so this is achievable with the node affinity. So what is taint and toleration and its use case? Sorry for spelling mistake. It's TAINT, taint and toleration. Taint, like there is an instance which is very unique, very in memory. It's a very high throughput or high memory available, and we want to make reserve this instance for this particular application. That can't be achieved with the above two. On above two, we are working on a pod that you will go to that pod. But here we are making the nodes node. We are giving the node a taint. What is taint doing? This it will not let any pod to schedule on that. Um, like I have 10 application. All after that I have only one application which require this high memory instance. Other one are working okay with the average kind of instance. So what we can do, I will give a taint on that, and according to I will pass the toleration only in the node which require that node. By this way, by doing this way, we can achieve the uh, we can achieve that on that particular node. Now only this application is getting scheduled, otherwise it is will remain free. Either it's completely free, but it will remain free. It will not let any other application to get installed on that. Okay, next move. What is the difference between daemon set deployment and application controller? So replication controller is we need to make a specific count of engine of pod. Like I already tell you, I have a Nginx pod, and I want to make its count 3 all the time. So what I can define, I can create a object application controller which will maintain the 3. But in today working, we are giving the replication set we are using, and on that replication set, deployment, rollouts and rollback is not possible uh, with by using deployment. We are creating replica set, but uh, we can add the policy like blue, green, others, and according to that policy, our new rollout, like version from version 1 to version 2 with no downtime can happen. And if something happen wrong, we can roll back to our old application. Okay, that's the story of the replication set and deployment. Daemon set is different from that. what daemon set do? Uh, we have 5 node on our current. In the daytime, our application scale up. Maybe it's a banking website. It scale up and worker node become 220. Okay, 20 or 25 they become, and in the after evening it will scale down and comes in the night time closer to 5. So uh, what daemon set do? It create the pod in all worker node. If I have 5 worker node, I have one pod of daemon set in all the worker node. Means I have 5 total pods. If it scale up and worker node become 12 25, and it will also auto scale the daemon set, and all the 25 nodes uh, will have one daemon set pod, only one daemon set. It will not more than one. So what is the use case of keeping a daemon set pod in the, like, uh, in the Prometheus we have node exporter who will send the metrics, and to get the metrics of Linux level, CPU, memory, we require some uh, agents or some pod on that particular node. So that's why we create the daemon set. And Fluentd, other application, we also create for logging also. Mainly daemon set is used for monitoring and logging. Okay, sorry. Can we run Kubernetes locally? Yes, we can. If you see on my videos, I am generally making videos on EKS because they are very popular these days. Nobody is creating their own Kubernetes cluster because it's become very challenging task. You need more people to handle it. With, if you see, if we can manage things like, if I explain to you, most of the companies which are using the on-prem system, they are now preferring the cloud system because cloud expertise, security, other stuff, you don't have to. You can concentrate on your business, and all the headache of making the Kubernetes cluster highly available, secure, they are shared by the cloud provider. So we can uh, deploy our cluster by Minikube. Minikube is the single node cluster. Uh, it is not preferable over prod. It is a single node cluster we can create by Minikube. We can create the cluster by using kubemedium, and we can create our own cluster also. We need to download the binaries and create the different component of the like, there are 4 component in the master, 2 component in the worker node. All we have to download the binary, and this run to this binary with the according to their parameter, but configuration we require. So we can configure our Kubernetes cluster locally. That depends upon your client, whatever organization, uh, what's their requirement. Okay, uh, PDB. What is PDB? Port disruption budget. If we talk about the port disruption budget, uh, we have a front end. We are again taking the example of Nginx, and we have made the deployment which is creating the replica is equal to 3. Okay, uh, is equal to 3, and we can think of the larger picture. We have the replica set at daytime equal to 10. It is get scale up, and to make the website live, make the website front page will come, at least it's come and show, and do the basic work. We require at least 3 of pod at any cost. We can't let our application to go beyond 3 pods. So what we can do, we can define the object pod disruption budget. What it will do, we can define minimum requirement, minimum available, like at any cost, our 3 pods will be created. So in case any plant activities there or any other stuff is there, it will, and other nodes are not available, it will not let the worker node to drain out unless new resources are available, and it will shift it to other resources. Then it will let the node to drain out, otherwise it will not let. In that way we can make, what are these steps we are taking? We are taking the steps to make our application highly available, because we don't want bad user experience. So these are the things we should configure, should keep in our configuration to make the our application highly available and to enhance the user experience. Okay, what is PV and PVC? Persistent volume and persistent volume claim. There are some application who are writing logs, making some data, and this data, because as we know, container lives is very short, pod lives is also very short. It will take, it can take restart, as we have provisioned the props. When we take restart, it will get deleted, and when it get deleted, new pod will be created which will not have the old data. So what we can do, we can store this data in a volume which we named as a persistent volume. This persistent volume can be on local file system, but most popularly we are using the cloud file system like Azure file share, and there are lots of solution are provided. Then we have persistent volume claim. When we created that particular volume, uh, we have to make the claim to used in the pod. Actually, we are creating all this stuff for pod only. So we will define that persist PVC, and PVC will be call under the pod, and whatever the data it will write, whatever the file it will make under that remote volume, and it will be remain saved. Okay, static and dynamic PV. Actually, memory is very costly, and whenever we are creating the infrastructure, we have to take care of the money. We have to take care of the money plus security. So uh, when we are talking about the PV, and we have made a PV, and after that we are making the claim, but it is not the best approach in today time. It is kind of approach of static PV. We have created a PV, and when we have created a claim after that, and we are using. But when no one is using, this PV is not useful, and we can say it is a wastage of resources and wastage of money also. So we can do that. We can make dynamic PV. Dynamic PV, that we can directly define the object PVC whenever we require, and like uh, we do by using storage classes in the Kubernetes. When we do the PVC, what it will do, it will create that particular amount of like I have created a claim, PVC claim of 10 GB. Okay, what it will do, it will create a PV at that time of 10 GB at that time also, and when we delete that PVC, that PV will also get deleted, but we will not delete that the PVC that much. So in that way we can manage the things and manage the money in best way, and our data will remain secure. So that's all from my side. If you have any suggestion, any feedback, you can please comment it out. Thank you. Bye.